So hi everyone. Just for a very short introduction, I'm here today with Andrea Galassi of University of Bologna, one of the NLP masterminds that made Claudette work. And my name is Kasper Drazewski. I work at BEUC, the European Consumer Organization. I had the privilege to work on the legal team of Claudette as my postdoctoral project at the European University Institute. Sorry, I apologize in advance if my voice plays tricks on me. My daughter's flu has finally caught up with me, so you have been warned. So some of you have heard the name Claudette. It's essentially short for clause detector. And the original idea comes from a conversation in the gardens of the EUI one sunny afternoon held by Hans Miklitz and Przemek Pałka, who was a PhD candidate in the law department of the EUI at the time. The idea was simple: to design software to see if you can design software that would detect and flag potentially unfair clauses in terms of service. I'm saying potentially unfair because ultimately the decision would belong to the court, but even potential unfairness would be a major step forward, for instance, for consumer organizations when dealing with unfair terms in consumer contracts. Let's go to the next slide. Since that sunny afternoon, under the generous supervision of Professor Giovanni Sartor and Hans Miklitz, the project has developed into a broad experimentation platform, bringing together 3 generations of young scholars ranging from the EUI, Modena Reggio Emilia, Bologna, and the Polish Academy of Science, among others. And also the scope has been broadened. Aside from detection of unfair clauses in terms of service, Claudette was now tasked with looking for compliance issues with privacy policies, with the GDPR, providing justifications for undeclared potential unfairness, where such potential unfairness was found. There's also a whole branch taking care of working on linguistic transparency analysis, which is also which is also supposed to increase accuracy of the unfairness analysis. Excuse me. And lastly, multilingualism. In short, allowing inputs and outputs in multiple languages. As we all know, if this is to be of any use to anyone in Europe, it has to work in other languages than English. Let's go to the next slide. Now, before I give you an overview of how multilingualism works in sense of the task we gave ourselves, this is how Claudette operates in the sense of preparation of data set. Human lawyers assign categories of potential unfairness to sentences they identify in the text of terms of service or privacy policies. As a result, here we have a jurisdiction clause example where the sentence would be tagged as fair if it if it confirmed the consumer's right to bring a dispute in their place of residence. Otherwise, it's tagged as unfair. And here we have an example from Dropbox. You and Dropbox agree that any judicial proceeding to resolve claims relating to these terms of services will be brought in the federal or state courts of San Francisco County, California, subject to the mandatory arbitration provisions below. So this is tagged as clearly unfair. And once a set of terms of service is tagged like this, it is used to train the algorithm. So how do we make this multilingual? Let's switch to the next slide. So this is the first approach, which is the easiest, where we simply machine translate input queries and the output. As a result, what is taking place is analysis is still run in English on the basis of the original English training data set. Again, I apologize. But the user then receives results which are machine translated to the input language. This is the easiest. Let's go to the next one with the pros and cons. This is the most straightforward to implement, surely, it only uses one training data set, which is great considering how much work it took us to prepare these data sets. But aside from relying heavily on the quality of machine translation, it is also very closely bound to the logic of the English language. And here we use the example of having a UK-trained lawyer with a great dictionary analyzing continental terms of service and privacy documents, which can make a difference or which might make a difference or not. And this is one of the areas we're working on to analyze. Let's go to the next slide. This is approach 2, and this is the one you've read about in the paper. We are talking about an automated building of a German training data set where a comparison would take place with German source documents with English counterparts machine translated from the English training data set. And on this basis, on the basis of such a reference file, we could then conduct a comparison, identify corresponding sentences, and then transfer the tags. And this way, semi-automatically create a German data set that would be then used to train Claudette to work on German documents. And the benefit of this approach, the major benefit of this approach, is that you are creating a new system for every language you integrate, which means there's a lot of room for fine-tuning the algorithms for each language. However, it also means you need to be very good at identifying corresponding sentences, and these sentences don't always want to correspond. Also, there are languages for which you have fantastic NLP tools, like for English, also for German. But there are also languages for which you cannot rely on their quality as much. So, but this is something the research teams are working on now to see what the differences are in a wider array of languages. So this is a bit beyond the remit of this paper. The major challenges we're describing in the paper related to the differences between documents, as in where you have the same content which is placed in different sentences in the other language version. Sometimes this would require that the categories are split manually. For instance, where one part of the message fulfilled the criteria for one type of category, in this case, content removal, and then the other part of the sentence that was extracted to a separate sentence, which tackled a unilateral termination of the contract. And an example is given here, where from the original sentence, which fulfilled both criteria, we reserve the right to delete or disable content allowed to violate copyright laws, and reserve the right to terminate the accounts of violators. The termination part in the German version was separate, and as such, the tagger had to reflect this in preparing the reference file. So this is one example, and the other one where we have one sentence in the English version which still fulfills the criteria for the same tag after it's split. And similarly to the case before, the human tagger needs to be cautious of this and manually evaluate the difference, and if needed, manually copy the tags to the neighboring sentences. As a result, where you had one sentence containing this information, you end up having two sentences, each of them tagged with the same clause, with the same category tag. So these are the two major types of challenges that human taggers faced when they were preparing the data set that we were working on for the paper. And now Andrea is going to give you a much more, I'm sure, interesting run through what was actually going under the hood of this project.
So, as Kasper said, this was our setting. So our problem is how to project labels from one document to another document that is in a different language. The semantic content is the same, but they are asymmetric. So the one document may have more sentences than the other. They may not correspond one-to-one. So we structured the problem as a classification problem in the to evaluate it. So we start with a source document in one language that is labeled and in the language LS, the language of the source document, and we want to project the labels to a target document in a language LT, language of the target, that is unlabeled and in a different, and obviously in a different language. So how can we do this? First of all, we want what are the features we want to have in our system? We want obviously it to be accurate, to perform correctly. We want it to be computationally efficient, to be used on large data set, large corpora. We want it to be unsupervised, and we want it to be language agnostic, so we can use it for whatever combination of languages, not only between the languages we are approaching now, but we want to design a system that may be used even in the future for different corpora in different languages. So the first step, as Kasper has anticipated, is machine translation. So in this example, we translate the target document in the same language of the source document. We translated it source-wise, sentence-wise, sorry. So each sentence is translated. We use an off-the-shelf tool. We have used Apache and Joshua, but other tools are possible. And and obviously there is a correspondence one-to-one between the sentences in this translated target document and the original target document. So now we have a simpler problem. We need to project labels between a source document and another asymmetric but parallel document, which is in the same language but is asymmetric, so there are differences between the two. So our problem now becomes how can we match the sentences, and the problem here, we can decompose this problem along three different dimensions. We want to match the sentences according to their similarity. And so we have to analyze, we analyze three different dimensions. First of all, the matching algorithm, so the criteria that are used to match each sentence. Then we have the sentence representation. So how do we represent this sentence, as a simple text or through numerical embeddings? And the similarity algorithms that we will use to compute this match. So first of all, I'll go with the matches first, and then we will address the representation and the similarity algorithm. So we follow a top-down approach. So the first algorithm, the most naive, let's say, is to associate each target sentence to the source sentence that is most similar. So we take the target sentence number one, we look at all the sentences of the source document, we compare them, we found the most similar, and we do the association. And then we do the same for all the other sentences. In this way, all the target sentences are associated with one and only one sentence of the source document. The sentences of the source document may be associated with zero or even multiple sentences of the target document. As you can see, sentence number 2 and 3 are not associated with anything. And also another thing that is important, that with this method, crossings, we call them like that, I don't know if there is a more proper term, between matches are allowed. As you can see, they cross each other, the arrows cross each other, which is something that it may be a feature in some context, in some data. In our context, we don't want this, because we have seen that usually the content of the documents appear more or less in the same order. So we want to avoid this with these crossings. So we have decided to use an algorithm that is used to align time series, which is called dynamic time warping, which is based on the dissimilarity between the elements of the two series. And it enforces the same order of the elements. As you can see in these pictures, in this picture, there are no crossings between the matches. In the picture, we are aligning the signal, the sequence, the blue sequence with the red sequence. And as you can see, it is possible to associate each element of the red sequence with at least one element of the blue sequence and the other way around. So there is at least one match, and even multiple ones are possible. So using this in our setting resulted more or less in this. Once again, we are enforcing to maintain the same order in the matching, so there are no crossing, and this is something a desiderata in our feature. And also, since multiple matches are possible, a sentence in the target document can receive labels from multiple sentences of the source document. For example, you can see the target sentence number 2 has received both the label L1 and the label L2. So this allows us to address some of the discrepancies. If we have a source document where 2 sentences contain different content, and then they are merged in a single one in the target document, we can address this problem. Okay, so this was our approach for what concern the matching. We have left out, obviously, the similarity. We need to compute these matches. We need the similarity. Before going to the similarity, we go into the. Sorry, there's another slide first. Sorry. So this is our approach. We translate the target document, and then we match the translated document with the source document, and then we can project the labels from the source document to the translated target document to the final proper target document in the original language. So, as I was saying, we need to compute these matches using a measure of similarity. Since the representation of the sentences has a huge impact regarding which measure of similarity we can use, we will see them first. So we can represent the sentences. Well, obviously the baseline is the textual representation, so just text. Otherwise, we can use sentence embeddings. I don't know how many of you are familiar with embeddings. Long story short, they are a way to represent the textual content in a numerical representation through a numerical representation. So we convert each sentence in a numerical vector, and the numerical vector captures the semantic meaning of the sentence. So basically, this similar sentences that have a similar semantic content are transformed in similar embeddings that are mapped in close to each other in a multidimensional space. So, for example, this is an example of word embeddings. So as you can see, each word is mapped into this two-dimensional space, and words that have a similar meaning are mapped close to each other. We have decided to use Elmo embeddings. I will go briefly into the reason we have chosen Elmo. Is because, first of all, is very computationally efficient, is contextual, which means that the representation of a word does not depend only on the word itself, but on the context. So we can disambiguate words. The same word in different contexts will have a different representation. And we create the sentence embedding as the average of its word embeddings. This is a naive approach, I will say, like it's not very, there are better approaches that we will talk about in the future direction. And also we have chosen Elmo because there are a lot of the for working in the English language. So now we adjust the dissimilarity measures. So for the text-based approaches, we have considered 3 different approaches, which are the edit-based distances. So they measure how many characters are different from one sentence to the other. Token-based approaches that measure the number of words that are different, and compression-based approaches that that first they compress the sentences and then compare the compressed version of those sentences. It's important to underline that in most cases, edit-based approaches are very costly because they need to measure all the differences between the characters. So they are the most computationally costly approaches. For the embedding-based approach, we have simply used standard mathematical dissimilarities for numerical vectors. We use the Cousin dissimilarity and the Bray-Curtis dissimilarities. So, experimental setting. We evaluate this our work as a multi-label classification task. So we compare, we take an English document, a labeled English document. We project the tags from the English document to the German version of the document and translating the German into English. And then once we have done the projection, we compare the result on the German document. So we compare the projected labels against the labels that were assigned to that document by the human annotators. I don't know if you are familiar with the metrics that are usually used in this kind of task. We will use the most important metrics will be the F1 metric. And long story short, if we reach 100%, so 1.00 is perfect, we have done the perfect job, which may not be possible even for a human person, because as Kasper has explained, there are discrepancies. And so projection may not lead to the perfect correspondence, even if it's carried out by a human annotator. So not a human annotator, sorry, by a human expert. So a human project, a human person that does projection by hand may not achieve 100% result with respect to what has done the annotator. So the results, I will try to not take too much time. I will just explain very briefly, if you're not familiar with these metrics. The first row, so the macro F1, consider each class of labels as equal. So even if one class is appears very rarely in our dataset, it's important exactly as much as one that is very common. The F1 micro is the opposite. So the more a label is present in the dataset, the more is important. And the F1 weighted, long story short, is something in between. So in this slide, we look at the baseline match, so the direct match. And we first analyze the results in the different approaches of textual similarities. We can see that the best results are achieved by the edit dissimilarity, the more complex edit-based distances, which are also the most costly. So the distances that are more computationally efficient are the worst. So this is not something really nice for the textual approaches, and still the numerical result we achieve is quite low. We achieve 0.6 more or less, which is not that good. If you compare the textual approaches against the embeddings approaches, that are the one circled in green, we can see how much better the embedding-based approach are with respect to the textual one. And also, once again, embeddings approaches are very computationally efficient. Because we need to compute the embedding of the sentences just once, and then every time we compare, we do the similarity, we do it very fast because we use mathematical libraries that are very efficient with respect to the textual based approach. So we can see that if we use the baseline matching algorithm, the embedding based approach is absolutely better than the other. And then we can look at what happens if we use the DTW. We can see that the differences in the text-based approach becomes smaller. More or less, all the text-based approach perform similarly. Well, the compression-based approach, which is NCD, is the worst one. No, neither one which is worse. Whatever. But more or less, they are on the same range. They are from 0.7 to 0.8, a bit more than 0.8. So the DTW has brought a great improvement and made all the approaches similar to each other. Especially, once again, it's important to remember that, for example, the Jacquard distance is very efficient and it has achieved great results. So it would be a perfect candidate. But if we look once again to the embedding-based approach that are in green, we can see that they are even better. They achieve a few points more than the textual-based approaches. So once again, the embedding-based approach is computationally efficient and brings good results. If we compare the DTW with the baseline approach, we can see that the use of DTW brings a positive contribution in all the metrics. The most for the textual the text-based distances, it's even bigger. For example, we go from 0.2 of Hamming to 0.78, so big contribution, and a smaller contribution for the embedding-based approach, but it's still a relevant contribution. We still gain 5 percentage points, more or less, in our evaluation. So DTW improves the performances of all our approaches. And I've almost finished. Just a quick thing: our corpora included 2 types of contracts, terms of service and privacy policies. We comparing the approaches, we have seen that that all the approaches were better on privacy policies with respect of terms of services. We think, we speculate it may be because privacy policies have less discrepancies than terms of services, and also have distribution of the labels that is more uniform with respect to terms of services. But we are not sure about this. It's just a speculation. Summing up, so our aim was to create to design a method to create parallel corpora in different languages in automatic fashion. We wanted to do this to be able to train new machine learning systems such as Claudette in their own languages. We wanted to be language agnostic as much as possible and supervised. In our method, has 2 requirements. The first is an automatic translation tool between the 2 languages or from the 2 languages to a third one, and the availability of sentence embeddings in one of these languages that will be used to do the matching. Our results were the best result we have achieved were with the DTW algorithm and using sentence embeddings with respect so proving that textual-based approaches were less efficient and less precise. Finally, and I will conclude, alternatives and future works. First of all, the direction of the translation. So in the example, we have translated German documents, so the target, into the language of the source, so English, but we are not sure if there are if this may be always the best approach. Sometimes it may be better to translate the source in the language of the target, or both the language in a third language. So we don't know. Like, for example, if we want to project from Italian to Polish, we may want to switch and translate both documents in English, or maybe not. We are not sure. We want to investigate still this. We have used an off-the-shelf and an open source translation tool, while maybe using a better translation tools, so professional translation tools, mainly to better translation and maybe to better projection. We don't know. We have done some preliminary experiments, and we have achieved a small but positive contribution. So also, as I already said, we have used a kind of naive mean of create sentence embeddings. More advanced methods are available in literature. And finally, another approach may be, instead of translating and then creating the embedding, we may want to use multilingual embeddings. There is a lot of work in the NLP community about multilingual embedding. So we map sentences from any language in the same numerical space, the same multidimensional space. This would remove the need of a translation tool. So that is obviously a positive thing, since we remove noise from our method. But at the same time, we may be limited on the possible languages, because we need to, we can use only languages that are covered by these multilingual embeddings. So pros and cons. We are currently planning to investigate this direction. And that was it. I hope that everything was kind of clear. If you have any question, and yeah, more details are in our paper that you can find published at that calling this last December. And yeah, that's it. Thank you for your attention. And obviously, I wanted to
thank you very much.
I wanted to thank you.
Thank you very much, Andrea and Kasper. So, Monika, would you like to share thoughts on the work that Andrea and Kasper presented?
Yeah, sure. I have some slides, basically more to help me with remembering which points of the discussion I want to bring, but let me share my screen. That's the last one. All right. Can you see it in the full screen mode?
Yes,
okay,
yes.
perfect.
Yes.
So Jan already introduced me at the beginning, but for those of you who came a little bit later, my name is Monika Leszczynska. I'm an assistant professor of empirical legal research at the Maastricht University Faculty of Law. Now, two disclaimers at the beginning of my discussion. So first of all, I'm by no means an expert in NLP, so I will not be able to discuss and to, you know, kind of bring any points regarding the technical parts of the paper, but I think that we have enough in the audience, we have enough experts on this topic that will probably bring it in the discussion afterwards. And the second disclaimer is that, of course, my comments are based on the paper, right? So there are like some things coming up here that were maybe not covered in the talk, but I will explain kind of where these points are coming from. And I also wanted to, something that I forgot at the beginning, I also wanted to thank you, the organizers, for inviting me to read this paper, because it was like a really interesting read. So thank you very much. So let me start with what I really like about the paper. I really like that that it addresses like a very important gap, right? So basically the lack of legal text analysis tools in languages other than English. That's like really cool. And it also, it's important because for several reasons. So first of all, it of course saves like a great amount of work. So annotations in each language will not be needed. So the authors, like in the paper, you didn't mention that in the talk, but in the paper you mentioned that it could be useful for documents produced especially at the European Union level, such as directives that are then translated into all the languages of member states, or regulations, court decisions, and so on, right? So this is like a really great and important work. Now, another issue that it addresses is that even if you use like crowdsourcing annotators to annotate your documents in other languages, in some languages you may actually have issues with finding enough annotators, like expert annotators, right? If you want to annotate documents in Czech, for instance, this may be pretty challenging to find enough legal experts from the Czech Republic, because it's just that not many people speak Czech, right? And then finally, what the authors also suggested in the paper is that, if I understood correctly, this approach could be then applied to other types of documents. So not only the terms of services and privacy policy, but also what I mentioned at the beginning, to, for instance, directive regulations and decisions of courts, for instance. So I really, really like that. But I do have some questions and comments, first to the data set and then to the results. So let me start with the data set. So you used like the terms of services and privacy policies for your analysis. And I've struggled a little bit like mapping the categories from this paper, right, that you presented today, to this Claudette meets GDPR paper. So in the Claudette meets GDPR paper, there are like altogether, I think like 22 categories of terms that were coded there, annotated there. And here you focus only, I think, on 8 from the privacy policies. I was kind of wondering why you decided to narrow it down to only these 8, why you kind of dropped the rest. I was like a little bit like kind of confused here when reading the paper. And then kind of related to that, when I tried to map these categories and I looked at into the Claudette meets GDPR paper, I've noticed that, like, I don't want to nitpick here, right? But I've noticed that most of them, they refer rather to clauses that were coded with respect to how informative they are about like the data protection rights, not so much about the fairness issues, right? That was my impression. So that's like kind of like a very small remark here. But then I have like another issue looking like at how you introduce the data set. So you first showed like tags that were annotations that were conducted by humans, right? So we have like this nice table in your paper. I don't know whether like the audience here have the paper open, but there's like table 1 introducing how many tags were assigned to documents in German and English. And of course, like you mentioned that like the issue of discrepancies that in German documents, there were like much more tags annotated, right? That like much more tags occurred in German documents. And you explained it by saying that basically it happens very often that one sentence in English is, you know, like translated basically into 2 sentences in German, right? So my question here is whether these discrepancies are really a result of just, you know, more consequence of more sentences in German versions, or maybe it could happen that the German version actually was different content-wise. So maybe there were like just small words that were different in the German version that, you know, led the annotator to assign a different tag, like an additional tag to this sentence, right? That didn't occur in the English version. Because I can imagine that there, even if you have like the German version and English version that is supposed to reflect each other, some small words may cause like differences in tags associated, I think, especially for those clauses in privacy policies when they regard how informative the clause is, right, about the rights of data subjects. So that's kind of like my comments and questions also to the data set part. Regarding the results, I do also have some questions slash comments here. So first of all, I wanted to go back to this point that you raised also in the talk, that you observed like better performance when it comes to privacy policies than when it comes to terms of services. So actually looking at this, going back to this table 1, right, that was like showing the number of tags in German and English documents, I would expect the opposite. So my impression was just by, you know, comparing the numbers, that the discrepancies were higher actually for the privacy policies, right? You had like even more tags associated with German documents, which would, you know, indicate if it's because of the number of sentences, right? In the German version, that would indicate that more discrepancies were in privacy policies. But I mean, I'm not sure. That's kind of unclear to me. So I'm like wondering what's your answer here. And then the second point is that in your paper, you worked with 5 privacy policies and 5 terms of services. And I'm not sure, as I said, I don't know the technical part, but isn't not the problem that you work with such a small number of documents here? I mean, does it have like any implications for your results? So that's kind of like a question. Then a comment. And then my final comment goes back to one of like actually good points that I read, that I mentioned at the beginning, but I'm wondering to what extent that's actually possible, right? So just let me elaborate on that a little bit more. So let's say that you would like to use such annotation projection for European Union regulations, right, or directives. And we know that we do sometimes have this problem of loss in translation, right? I mean, that version of GDPR looks really different than the English version, right? So there are some provisions that, I mean, if you ask like a Dutch lawyer, he or she would interpret that completely different than like a person who read the English version, right? And I'm wondering whether that will not be a challenge to what extent this kind of approach with annotation projection can actually be used, right? Even if they are developed on the English version, but the versions in other languages are including these very small words that are changing the meaning, whether this will not be a challenge for such an annotation projection, and whether it will very much depend on what types of annotations you are conducting, right? Whether you are just classifying, let's say, the kind of like the topics of these clauses, or whether you go into more like a subtle tags here, right? Whether you want to really, you know, for instance, in this, the Claudette meets GDPR, right? You have these free tags for classifying how informative the given clause is, right? That is already a pretty subtle, I would say, tag. And sometimes the distinction can really depend on very small words, right? I mean, like word differences. So I was wondering to what extent such an approach would be useful if we have these issues of lost in translation when it comes to different documents. And yeah, this is it. Thank you very much. And I will stop sharing the screen. And I'm curious about the answers of the authors.
Thank you very much, Monika. So Andrea and Kasper, any thoughts on the points of Monika?
Thank you so much for this, Monika. This is a very detailed analysis. I will try to address the points you mentioned from the perspective of someone who was working on the tagging team and certainly is responsible for some of the issues you're putting forward. So regarding the different numbers of tags and substantive discrepancies, I think it's important to keep separate the sheer number of sentences which were tagged and the actual number of potentially unfair clauses that were the potential issues that were isolated. And this is because one thing that I've noticed as when I was working on transferring these tags to the German versions, one thing I noticed is that the German formulations are much there is a different type of structuring of text often involved. And by that, I mean English drafting seems to have endless patience for the length of a sentence. This I have not seen in German. Whenever the sentence was coming close to risking being too long, the German drafter would simply put a full stop and continue in another sentence. In a way, this made the German structure much easier to read. So I think this is what, and I think I think I saw this even more in privacy, but I would have to have another look at the data set. Right now, I don't want to lie to you. But this was prevalent throughout the transfers of tags that I did, and this is the major difference. Now, it is true that this data set is small. This is more of a proof of concept than anything else. There is a bigger data set in the works now containing 25 documents in 4 languages. I'm sure those results will be very interesting when put against these. What is important is also that we wanted to test the concept rather than jump to having a tool that would be able to address all types of discrepancies. Because in the real world there are much more types of discrepancies than these, and for the time being we simply rejected documents which were too different. In privacy this was easier probably because substance-wise the content was essentially the same. Also the structure of the policy, the message so to speak, all of that, there were very few changes. But when you delve into terms of service, for instance, and I saw this with the 5 document data set, I saw this again with the 25 data set, especially when comparing the international English version to the German version of terms of service. you will notice that German terms of service tend to be slightly more fair than the general international version. I don't want to speculate on why this is the case, but there is a tendency that there are fewer unfair clauses, that there are sometimes fewer exceptions, which are morally dubious, so to speak. Sometimes there is more regulation to give the consumer more rights. But there is, in that language pair, English and German, in terms of service, is definitely the most interesting for studying such discrepancies. You asked about the categories we used in privacy. For this, I owe you some background explanation. There were two approaches to privacy in Claudette. The first one was more of a general one, where we weren't really sure about how to find a set of categories that would capture the biggest problems that privacy policies pose. And then after about, essentially this was around summer 2019, so we've already been working on privacy for more than half a year. We noticed that while certain categories need to be redesigned and split to ensure more resolution, like for instance transferring data to third parties, needed to indicate whether that would be a data controller or a data processor, or for perhaps a user of the service. Before we did not, we hadn't thought of that distinction playing a major part. Later, our results proved that it was a good idea. Some categories we dropped because, for instance, we spent considerable time and effort trying to rulify vagueness. And vagueness was something we decided that simply, as many research efforts conclude, more research is needed. Essentially, this is a task that the linguistic transparency team is now working on. It's now a separate project under Claudette to try and crack this, because once this is done, this will also pave the way we hope it will pave the way to much more sophisticated textual analysis, to being able to do something Claudette is for the time being not able to do, which is combining pieces of information which are distributed widely in a large document. So for instance, for a human reader, where you have a mention of defined terms in the beginning of a policy, and then these terms are referenced 20 pages later, you're at least expecting the human reader to remember what these mean, and on this basis the reader will decode the meaning 20 pages down. For a classifier that only looks one sentence ahead, one sentence back, this is impossible. And yet it is crucial when you're evaluating the clarity of a document. So this is one of the challenges that the linguistic transparency team is dealing with. We are, unfortunately, the colleagues who are working on that were unable to join us today. I had silently hoped that they would, because that they're really dealing with one of the most difficult questions that there are, and yet inevitable.
If I can add something, in the paper, like in the table of the paper, when we report the composition of the dataset, we report the classes only of the tags, only the main classes, but each of these classes is then split into different degrees. So for example, for data used for advertising, which is AD, we have actually AD1, AD2, and AD3, which represent the degree of unfairness, let's say. So we haven't reported that clearly in the table because of space, but the dataset actually contains, for each category, 1 or 2 degrees. So they are 21 in total. if my files are correct, we for privacy policies they are 21, and for terms of service they are 27, because each of these categories then split. Yeah, we should have been more clear in the paper regarding this. It's something we may have overlooked when we have written it, I think. But yeah, just to cover that. Sorry, if you want to continue, Kasper. Otherwise, I will answer to the question regarding the discrepancy between terms of service and privacy policy.
Please go ahead. I can go on like this forever. So.
Okay. So regarding the discrepancy between privacy policies and terms of service, it is true that if you look at the number of tags, for example, in terms of service goes from 153 to 190, more or less, so not that much more, while for in privacy policies goes from 260 to 350. So there are many more tags in the German version. But if you look at the proportions of these classes, maybe I can share the screen very quickly to show you. Just a second, because so I'm not talking about concept. I'm trying to talk about something. Okay, you can see this Excel, right?
Yes.
Okay, so if you look at privacy policies, these are the composition of the German data set. So these are all the labels and their percentages, and this is the English version. If you look at them, more or less, they have all. It's not very easy to read. I admit. It was more of like for our internal use. The percentages are more or less the same. They are different. Like for example, basis one goes from which is in blue, goes from 9% to 10%. Catch 2, which is the big ochre one, it goes from 25 to 26. So more or less, they are kind of the same always. If we go to terms of service, we can see that the difference in the composition of the corpus is more pronounced. Especially if you look at LTD2, which is the green one, the small green one, goes from 20% in German to 16% in English. So 4 percentage point of difference. And the same goes from the other green one goes from 20 to 22. So the difference between the composition in the data set is regarding the distribution of the classes is a bit more pronunciated in terms of service corpus. This is what we meant by discrepancies in differences in the two corpus. Not only like in privacy policies, there are more discrepancies regarding the number of sentences, but the distribution of labels more or less remain the same. It's more proportionate. Yeah, I think it is an English word, and yeah, that's it. I hope that it covers the question. And yeah, I don't remember if there were other questions regarding the results. I don't know. I leave it. This was the answer, and have we covered everything, or there are still open doubt?
I think that most of the issues were covered, but I will. I still have some comments, but I will like give the floor to others. So.
Okay, thanks. Any questions from the audience?
Oh, yeah, I will just add one thing, since I remember. Sure. As you said, can we extend this to other type of contracts? Well, this method we have designed works in our case study, where I think we have highlighted the features of this contract, that they have the same semantic content, and more or less the content appears kind of in the same order. So if we take different type of contracts, so where the content changes a lot, or the order of the elements changes a lot, we may want to change the algorithms and the methods we are using. So I mean, it's kind of, we have tailored this method also considering which were the characteristics of our documents.
All right. So are there any other points from other people here? If not, I think, Monika, you had a few more.
I have a question, if I may, until everybody else is getting a little bit warmed up, perhaps for other additional questions. I just wanted to ask you both, but perhaps Kasper, specifically you, if I may. So from a legal perspective, I think if we speak about legal translations, then we go into this dimension of comparative law, where we can't really find always functional equivalents for concepts that are legal from one jurisdiction to another. So if you're speaking about, perhaps, I don't know, if you have the word trust in English law, and like the thing that just comes to my mind right now, if you have the word trust, and then you have to think about, okay, how do you formulate this this concept, which also for the computer scientists in the room, it's basically just holding a part of patrimony for someone else, right? So it's you are actually, you have certain rights to, let's say, money, but it's not yours. You're holding it for someone else. So we have a concept in law for that. But then depending on the different jurisdictions that you might look into, this concept is going to be formulated differently, and it might have different functions. So how do we overcome these issues and the concepts of law that we see very much if we do just a very basic comparative law research? How do we identify these issues in computational work, and then how do we overcome these issues from a computational perspective? I'm very curious what you think.
Thank you for this. That's a very good question. So I would say, actually, the example you gave of trust is, I would say it's relatively easy because you don't translate it. It's such a unique creation construct that trying to find an equivalent in continental law would be just too risky. I spent some time studying legal translation before my time in academia, and this was one of the no-go zones, so to speak. Essentially, if the translation is to have value and to be used in court, if it simply cannot make these parallels. So I think from this perspective, I think this also needs to frame addressing the way I address the problem you mentioned, because the problem very much exists. It's just it just needs to both differentiate between concepts which are unique to one law and not found in the other, and then be able to translate those which do have equivalents. And with this, at some point, I only have a working theory on this, and I have not verified this with our data scientists, but from my own observation on how systems like Claudette behave, the larger sample they have, the better they are at identifying these correlations. And I'm basing this on seeing how the efficiency of identifying potentially unfair clauses increased when we were working on justifications. In other words, when the system not only had the reference files of which were used to train the algorithm where the unfair clauses were tagged, but also had a table with potential explanations for unfairness, the accuracy of identification of unfairness increased. But again, this is just my working hypothesis. Maybe Andrea can say a little more about this, because I feel I'm out of my depth here.
Honestly, I'm not sure. Honestly, I don't think I can add too much to what you have said, because I'm not the one that is actually covering that experiment. Another person in our team, which is Federico Ruggeri, and maybe he's the one who may answer to this question.
Okay, so for the time being, let's just say that there are some but that there are some concepts which the human tagger must be able to identify as non-translatable. I think this is the clue. This is the crucial point here, at least for the time being.
Maybe just as a follow-up, I just want to say that so at Maastricht we had, so right now he is an emeritus professor, but we had a professor who was absolutely maybe one of the pillars of legal translation and comparative law, René de Groot. And he actually had this really beautiful methodology of legal translations in 10 steps. And I think it would be really wonderful to bring him in, or bring him back from his emeritat so that maybe he can give us some suggestions or some of his own insights into legal translations, because for instance, no translation was actually one of his steps, and he had a beautiful decision tree in terms of doing legal translation. So maybe we can tap into this super old school yet super useful a category of knowledge that we have in comparative law. So maybe this is something for future events.
Sure. We are sort of running out of time, but if anybody else, do you have any other questions you would like to ask? Anybody else? Or Monika, maybe any final thoughts? Yep.
So, yeah, I still want to go back to one of my questions regarding to what extent it can be, used for regulations and directives, right? And something that I mentioned with the lost in translation problem. So, I mean, I don't really mean like different structure of documents. I mean like the exact same structure of documents, but using like slightly different words, right? So let's say that this document, like, German directive, right? Let's take it. And it was created in English originally, then it's translated to German. Then like in your method, you would then do first like an automatic translation of the German directive, right? And then try to project the annotations that were developed on the English version. And let's say that we have like basically one word, right, in the German directive is slightly different than what was in the original English version, right? That really changes the meaning, yeah, of the, and like in this case, like specifically, it would have been annotated differently by a human annotator, right, according to some, instructions that you give them for this type of annotations. Will it be picked up by, let's say that you run the comparison of, similarity sentences. So this one word that is very crucial for the tag, will it be picked up in the similarity? So, the method that you're applying will basically say, no, they are like different sentences. It will not assign the tag from the English version, right? So how it will be captured in like using the methods that you are suggesting, this type of situations?
Okay, as I said, we are using contextual embedding. So what does it mean? It means that each word is mapped in a numerical space according not only to that word, but also to its surroundings, its context. So I think if the word is different, but the meaning is the same, it should be mapped in spaces that are close to each other. So I think that it depends on the quality of the embeddings, but ideally, yes, this shouldn't be a problem. Ideally, the algorithm, the embeddings should be able to map the sentences according to their specific meaning, not only to the words that they are using, because they were created on a gigantic amount of documents. These methods, like the word embeddings, were trained on a gigantic amount of documents. So if there are ambiguous words that they can have multiple meanings, and these methods will check the surrounding words and understand what is the meaning we are using. The same works for synonyms. If two words are, even if they're different, but they share one possible meaning, if the context is the same, the algorithm should be able to understand that they are synonyms. Once again, we have tried only one type of embeddings. We are not, which was once again a bit naive. There are more advanced methods. So, but it's one of the things that we are planning, like right now, like this afternoon, we have done like a meeting with some students to investigate this direction. So try different embeddings, and then obviously check which are the cases, the error cases. What are we missing with this method? And so to understand if what you've said is actually a problem or not, because ideally, like if everything works perfectly, no, it shouldn't be a problem. Obviously, we need to see if this is the case. Also, this is my guess. I'm not sure about this. I would say that the words that are very technical, so like that have a very specific meaning only in the context of law, and that meaning is different from any other context where that word can appear, may, if it's an ambiguous content, they may create trouble if legal documents were not included in the training of these embeddings. But so in this case, one should check, like, when choosing which embedding which embedding to use, one should check what was the corpora on which these math with tools were trained, where they're including legal documents. So the knowledge regarding the legal domain was included in the creation of these techniques. And yeah, but I'm optimistic. Let's say I think everything should be handled kind of fine. I'm more concerned about some discrepancies that, for example, in some documents, if in the target document there is something that is not present in the source document, for example, there is some clause that is unfair and is only in the target document, not in the source document, it's impossible to catch that. Because if we start with the target document, if something is not in the target document, we cannot find it we start in the source. If something is not in the source, we cannot find it in the target.
Okay, thank you very much. I think we should probably stop here because we have exceeded our allocated time. Thanks again very much, Andrea, Kasper, and Monika.
Thank you for inviting us.
Joining us.
Thank you for having us.
Thanks again.